Okay, welcome back to the CS232 makeup lectures. Today we're going to be covering mathematics part 2 of C#. And let's go ahead and get started. So last time we talked about basic operations and operators, multiplication, divide, etc. We tried out computation for area of a triangle, Zamarin, and we tried out modulus operators, plus and minus operators. Those are unary operators, remember. We tried out compound assignment operators. Then we went on to input. We did some with console read line. And remember, you can use the convert class to convert this to integers or to convert it to floats or whatever you want to convert it to. We're going to go on and ask some questions here about what is 5 divided by 2. So this is actually a trick question. Normally you might say, well, it's 2.5 or it's 2 remainder 1. But in the case of computer science, especially when you're dealing with integers, oftentimes the correct answer is 2. That's what we call integer division. So in the case of integer division, 5 divided by 2 is 2. Just as, for example, 7 divided by 3 is 2. So integer division always leaves off the remaining fractions. Integer division, in fact, has no way of dealing with fractions. So fractions are just simply lopped off the end of it. That is actually, when we get to computer organization and architecture, you'll see that that's a efficiency thing, that the reason they don't deal with fractions is because fractions take up too many bits. So the fractions are just simply left off. So for example, 8 divided by 3 is 2, and in this case you'll notice that you might think, well, it rounds. It is not correct to say that integer division simply rounds up to the next largest integer. That is not what happens. Instead, it just lops off the end of it. So 8 divided by 3, for example, is 2, not, because that would be not 3, for example, for rounding up. So we've touched on this next topic a little bit already, is the idea of casting. For example, you saw this in my XP calculator, or my attack bonus calculator program that I ran before for you. I did what did I do here? I think in this case we didn't actually have to do it. Looks like all our computations were fine because we just did XP divided by 2000, and this is integer division right here. So we didn't need to actually do a cast. There was an example I showed you last time where a cast was necessary, and I can kind of draw up a quick example of that. For example, let's say that we wanted our XP to actually be a double. So in other words, if we wanted half XP amounts, which actually exists in some versions of D&D. So if we say convert to double, XP as string, now we're suddenly going to run into problems because we say int level equals XP divided by 2000 right here, and I will show you what happens in that case. It's going to give us a cannot implicitly convert type double to int. Now, it would not give us this error if we were going from integer to float, but since we're going from float to integer, there's going to be precision loss. In other words, XP is currently treated as a double, and we want to treat that as an int instead. So what we would have to do is we would have to take this, treat it as an int, then divide it by 2000. Then it shows that it does the integer division. So now it's doing integer division, and you have to do that because the loss of data, I'll show you what the loss of data looks like here. So let's say that our XP is 4000.5, for example. And for each level denominator is 2000. So if we would take and divide basically if we're going to divide 4000.5 into 2000, what we really want is the answer to be 2. This is the current level. There is going to be precision loss whenever we convert this into and want to get the result of 2, because there's a 0.5 on here, so this would obviously be something slightly bigger than 2. So that's what we mean by precision loss. The 0.5, and actually in this case it's going to be 0.25. Sorry, a second. That's going to be 0.25. So we're going to have 2,000 point, or I'm sorry, 2.00025. So in our case, that's what's actually going to be. This amount is going to be the 0.00025 is the precision loss when we convert this to int. So it's important to note that that is what you're essentially telling the compiler at this point in time, is to never mind the fact that there's going to be integer loss and explicitly convert that, or I'm sorry, there's going to be precision loss, explicitly convert that to 4,000. So that's what will happen if we, this is what happens if we do not convert. But if we take and put an int cast before the 4,000.5 divided by 2,000, this means we get 4,000 divided by 2,000, and we get 2. So it basically says, yes, I know there's going to be precision loss, and it doesn't matter, and go ahead and proceed on. So that is that is basically a simple example of casting. Now, that's a more complex example, but a more simple example, and one that does it implicitly for you, is, for example, if you say float b equals 2. In the above case, the integer 2 is going to be converted to 2.0. Floating point in this case, in this example, you can get plain and clear. Floating point is considered wider than an int because it can hold more data than an int. So it does the cast. Anytime you're going from a smaller value to a larger value to something that's wider than it, it'll implicitly do the cast for you. But if you're going down in precision, then you have to explicitly do it. So in our case, for example, we're going down from xp, which is a float, down to an int. So we had to explicitly cast this, and we could not do it implicitly. Here's another example of having to do it explicitly. This is in saying that, for example, 3.0 divided by 5.0 plus 1. The reason we need to do this, by the way, is that 3.0 and 5.0 are going to be considered doubles. That's what C# does automatically. Anytime you put a number down, it's essentially going to be treated as a double. So 3.0 turns out to be a double, 5.0 turns out to be a double. Doubles, or floats rather, are not wider than doubles. Doubles are wider than floats. It's kind of the reverse. So you have to do that conversion. You have to convert it to a float. So basically 3.0 converts to a double, 5.0 converts to a double. So we end up with a double result in here, and then that result has to be converted to a float. Now, in this last step, it's just going to convert the 1 directly to a float because, again, a float is wider than an int, so it has more precision than an int, so it automatically converts it over. And then you have the result of this 3.0 divided by 5 as a float added to the 1 as a float, and then it just adds 2 floats together. That's what we call an explicit cast. A couple other slightly more advanced math concepts, well, not really, because this is kind of something you've seen all along, is dividing by 0. Just like in any math class you've taken, you can't do this. However, what you should be aware of when programming it is that it will give you an exception if you actually divide by 0. We'll learn more about exceptions later in class and how to deal with those, but for now it just means your program will die, basically. It'll end. So what you should do is what we'll learn about in the next coming classes is using an if statement to check if the denominator is 0 before you divide it. A couple other notes on special number values. Double A is a positive infinity. Double dot positive infinity gives you positive infinity as a number, and that can be used to represent infinity, just like float dot positive infinity can give you the floating point representation for infinity. This can be very useful if you want to give something max value. Likewise, if you want to do this in ints, you can do so with max value and min value. These are useful tools when implementing certain things. For example, if we consider an algorithm that we want to find the minimum value of a list of elements, one thing we could do is traverse this list starting with a variable that holds the lowest value so far. You could set this originally to be the max value. Then for each additional item in the list, it'll be compared in turn. If it's smaller than the previous, it'll reset the value. This is kind of a thing we do quite often in early computer science classes, is sorting and finding the largest or finding the smallest. So let's say we've got a bunch of numbers. I'm just going to randomly create some numbers here. Now, if we're going through this, we're going to have something that we call lowest. We're going to say this is equal to the max. So you come in and you say, this next number is 1.6 smaller than lowest. Well, the case is that yes, it is. So now reset lowest equal to 1.6. And then it's going to say is 1.6 smaller than lowest? No. Do nothing. And that same thing repeats again. Is 1.6 smaller than lowest? No. Do nothing. And you see the pattern developing here. Anytime it's larger than the one you're comparing against, it's not going to be the case, so I'm just going to paste that in. Now, if, for example, we had added a 1.2 to this list, we'd say is 1.2 I'm sorry, this should say is 2.0, is 2.4, is 4.2, is 5.0, is 1.2 smaller than the lowest. Yes. Now reset lowest to 1.2. So just going over this again, basically we set the lowest to the maximum possible value initially. Then when we go into our first item, we can compare 1.6 against the lowest. 1.6 is smaller, so we reset the lowest to 1.6. Now we're comparing 2 to the new lowest, which is 1.6. 2 is not smaller than 1.6, so we don't do anything. 2.4 isn't smaller than lowest. 4.2 isn't smaller than lowest. 5 is not. 1.2 is smaller than 1.6, so we reset the lowest to 1.2. That's a common use. That's a common algorithm for finding the smallest value of a list. One last thing, there is a common way of incrementing and decrementing, which is essentially a fancy way of subtracting or adding just one to a certain number. We've found that we do this so often in programming that every language pretty much, since C++ allows you to do the plus plus operator and the minus minus operator. So for example, if we consider the following code where we have x equals 0, x plus plus, and then another x plus plus, x ends up being 2. Of course, if you did x minus minus, and then x minus minus, x would be negative 2. So this is just a fast way for us to increment or decrement by just one number. And that is it for this video. That finishes the week 3 content. You'll have a quiz posted sometime soon concerning week 3 makeup content, and take that by, I think we're going to have that due by Friday at the end of the week.